Alright, welcome to our notes on section 6.4. We're going to take a look at some word problems that involve some quadratic equations. Alright, so the first one, so some things to keep in mind before we dive into this. When we solve quadratics, we have some things in our toolkit. We could be dealing with factoring, we could deal with completing the square, and we can deal with the quadratic formula. So all three of those things are in our toolkit. We could also go with graphing, but if we're going to graph, sometimes it's a little tricky to find out those exact solutions. All right, so we're going to keep that in mind. We have some things in our toolkit. All right, so the first one, we're trying to find the two consecutive positive even integers whose sum of their squares is 580. All right, so if we're talking about even integers, we're talking about 2, 4, 6, 8, so on and so forth, and we know that even integers are 2 apart. So, because if we're talking about an even number, then we got an odd number, and then we got another even number. So if our first even number is x, our second even number is x plus 2. And if we're talking about the sum, we're talking about adding these together, and we're talking about the sum of their squares. So that means we're going to square both of those. So we're going to think about x squared plus x plus 2 squared, and we know the sum of this is 580. All right. So x squared, that's just x squared. With this x plus 2 squared, we're going to think about x plus 2 times x plus 2, and we're going to FOIL that stuff. And when we do that, we have x squared plus 4, I suppose I'll do it the long way. So plus 2x plus 4 equals this 580. All right, I can combine some like terms. X squared plus x squared is 2x squared. 2x and 2x is 4x, plus 4 equals 580. Okay, when I solve a quadratic equation, I want to make sure I set the whole thing equal to 0, so I'm going to subtract 580 on both sides. So 2x squared plus 4x plus 576 equals 0. I notice that all three of those terms are divisible by 2, so I'm going to factor out that 2. So I have x squared plus 2x, and then I have a minus 288 equals 0. All right, at this point I could think factoring, I could think quadratic formula, I could think completing the square, all that other good stuff. I'm going to choose to use the star method. I'm seeing that this stuff hanging out here is a trinomial, so one way to factor this is to use the star method. So hanging out in my A position, I have an x. My A times C, I have a negative 288. And my B term, I have 2. So I'm looking for numbers that multiply together to give me negative 288, but add together to get me positive 2. Okay, in this case, I want numbers that are 2 apart, one positive, one negative, and I have my factors of 18 and negative 16. All right. So when I factor this stuff, the 2's hanging out in front, and I have an x plus 18 and an x minus 16 equals 0. I know that 0 times anything is 0, so I have my 2 mini algebra problems. I'm going to think about x plus 18 equals 0. So in that case, x is negative 18 when I subtract 18 to both sides. And I'll think about x minus 16 equals 0, so x equals 16. Okay, if I circle back to the original deal with the problem, I'm looking for 2 positive even integers. Okay, so negative 18 is not a positive number, so I'm going to ignore that one. So I'm going to deal with my first number has to be 16, and the second even integer after that is 18. So my 2 consecutive even integers whose sum of their squares is 580 would be number 16 and 18. All right. All right, diving into question number 2, we're talking about a rectangular building that measures 30 meters by 25 meters. Okay, and it's going to have its area increased by 200 square meters by adding a strip of the same width to all 4 sides. So I'm going to increase this. The same strip is happening all the way around. I don't know how wide it is, but it's going to be x. Okay, so it's going to be the same all the way around. I can call that x. All right, so I want to determine the width of the strip. So originally the area was 30 by 25. So originally the area was 750 square meters. I'm adding 200 to it. So my new area is going to be 950 square meters. All right, so if I'm looking for the area of this new shape, I'm thinking, all right, it's a rectangle, so I'm thinking length times width. Okay, I know the area is 950 square meters. Okay, my length and width. Originally, I had 25 meters here, but I'm adding on an x and another x. So now I have 25 plus 2x. All right, talking about my width, I'm thinking about 30 plus 2x. So my area is going to be 30 plus 2x times 20 plus 2x. All right, so 950 equals, all right, and I'm going to FOIL here. First terms, 30 times 20, I get 600. Oh, whoops, I've screwed it up here. Oh, that's not 20. That should be 25. All right, can't read my own writing. Sorry about that. That should be 25. Okay, there we go. So 30 times 25, I have 750. Outside terms, I have 60x. Inside terms, I have 50x. And last terms, 2x times 2x is going to be 4x squared. I'm going to set this whole thing equal to 0, so I'm going to subtract 950 on both sides of my equation. Oh, negative 200. Sorry about that, people. While I'm at it, I'll add some like terms. All right. All right, so let's try this one in terms of that quadratic formula. All right, I'll shrink this down a little bit. Okay, so quadratic formula, in this case, my A is 4, my B is 110, and my C term is negative 200. My quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so negative b, I have negative 110 plus or minus the square root of 110 squared minus 4 times negative 200 all over 2 times 4. All right, I'm running out of room here. All right, shrink that down. Okay, if I evaluate the discriminant here, I'm looking at 110 squared minus 4 times negative 200. So that's going to turn out to be the square root of 15,300, all divided by 8. Okay, if I evaluate the square root of 15,300, I'm talking about plus or minus about 123.7 over 8. Okay, I know I'm dealing with two problems. One with the addition symbol, and one with a subtraction symbol. Okay, if I clean up that first one, negative 110 plus 123.7 divided by 8, I get about 1.7 meters. Okay, this other one I'm not even going to worry about because I know negative 110 minus 123, that's a negative number divided by 8. I don't need to worry about negative numbers because that would make my area smaller rather than larger. Okay, so here's my one answer that I'm going to be concerned about. I know that I'm adding a strip of about 1.7 meters wide to the length of each side of my rectangle in order to increase the area by 200 square meters. All right, we got one more to go. All right, and we're talking about the hypotenuse of a right triangle. Little typo in here. The hypotenuse of a right triangle is 3 centimeters longer than one of the legs and 6 centimeters longer than the other. We want to find the lengths of the sides. All right, so I'm thinking about a right triangle here. I don't know how long the hypotenuse is, so I'm going to call it x. If it's 3 centimeters longer than one leg, this leg here would have to be 3 centimeters shorter. If it's 6 centimeters longer than the other leg, so this bottom leg might be x minus 6. We can think back to Pythagorean theorem that says a little a squared plus b squared equals c squared. Okay, I know that my longest side has to be c, and I can plug in x minus 3 for a, for example, and x minus 6 for b. If I had those flip-flop, I'll still end up in the same spot. Okay, x minus 3 squared, that's, remember, like x minus 3 times x minus 3, plus x minus 6 squared, which is x minus 6 times x minus 6. Okay, so I can FOIL some business hanging out over here. I'm going to have x squared minus 3x, which gives me minus 6x. Last terms gives me 9. Okay, taking a look at this next chunk, x times x is x squared, minus 6x gives me minus 12x. Last terms I have a plus 36. All right, so taking a look here, x squared plus x squared gives me 2x squared, negative 6x plus negative 12x gives me negative 18x, and 9 plus 36 gives me 45. And that should be equal to x squared, not 0. Okay, I need to set this thing equal to 0, so I'm going to subtract x squared on both sides. All right, I'm running out of some room, so I'm going to shrinky-dink this down. Okay, which leads me to x squared minus 18x plus 45 equals 0. All right, so we can star method this up. So I'm looking for, okay, in my first position I have x. Up top I have 1 times 45, which gives me a positive 45. And on the bottom I have my b term, or negative 18. So I'm looking for factors that multiply together to give me 45, but add together to give me 18, negative 18. Okay, those factors are going to be a negative 3 and a negative 15. So when I factor, I have x minus 3 times x minus 15 equals 0. I have my two mini algebra problems. Okay, so breaking it off, I have x minus 3 equals 0. Add 3 to both sides, so x is 3. X minus 15 equals 0. Add 15 to both sides, so x is 15. All right, so let's check this out. All right, let's see. Do both of these make sense in the context of our problem? All right, so if x is 3, this side over here would be 3 minus 3, or 0. And this side over here would be 3 minus 6, or negative 3. It doesn't make sense to have a side length of a triangle at 0 and another one that's negative 3. So this thing is not going to work in this particular application. That's not a triangle. So let's check out this next one. So if x is 15, okay, x is 15, lovely. 15 minus 3 is 12. And 15 minus 6 is 9. All right. Having a triangle with side lengths of 9, 12, and 15, that makes sense. So that's going to be the 3 lengths of my triangle, and I'm dealing with things in terms of centimeters. All right, that's it. Please let me know if you have any questions. Good luck.